Imagine pouring like 30 years of your life into an open source project. You watch it grow, you see it evolve through different programming languages, it gets incredibly sophisticated, only to decide, after all that time, to just, well, abandon it completely.
Yeah.
What could possibly lead someone to do that? Especially when the core idea, you know, the reason for starting it, still seems really valid. Today, we're diving into exactly that kind of story. It's this fascinating journey of the software developer and their really long-standing project. We're going to explore this powerful philosophy for document maintenance they developed called Program Enhanced Text, or PET for short. We'll unpack its history, how the tech evolved, and kind of surprisingly, why it didn't really catch on in the industry, at least not initially. But here's where it gets really interesting, the real game changer. We'll look at how the rise of large language models, LLMs, has completely reshaped the whole landscape for this exact idea, making it, well, more relevant than ever. So today, our mission is really to dig into why this incredible 30-year software project got shelved, even though the main idea behind it is still so powerful. And maybe more importantly, what does all this mean for how you might think about creating and maintaining information in today's world? Let's get into it. Okay, let's wind the clock way back to 1996. The beginning of PPT, it came from a really practical problem, a relatable developer pain point. This developer was writing documentation for their script basic interpreter. You know, the usual thing, needing to include code samples and the output from that code right there in the docs. Now, anyone who's done that manually knows it's just copying, pasting. It's incredibly tedious and error-prone, right?
Yeah.
Especially when the code changes, which, let's be honest, it always does. That's a classic developer headache.
Oh, absolutely. A total classic. And that specific everyday frustration, that's what directly led to the fundamental philosophy behind PT, which is, simply put, anything that can be maintained automatically in a document must be automated. Because think about it, conventional documentation is just often full of redundancy. You copy version numbers, maybe from a Maven pom.xml file. You copy configuration strings from code, maybe code snippets from unit tests. Manually duplicating all that stuff just invites inconsistency the second the original source changes. Pete aimed to kill that problem, enforce a single source of truth by linking directly to the code or the data itself.
Okay, that makes perfect sense. We're addressing a really critical pain point. But I can also imagine that enforcing that single source of truth might have created its own set of headaches. No.
That's a really good point, yeah. While it solves the consistency issue, it does introduce a dependency. If your documentation links to, say, a piece of code, and then that code changes or moves, the documentation tool might suddenly throw an error, which, as we'll definitely see later, became a pretty significant hurdle for adoption. People don't like their doc builds failing.
Interesting. Okay, so from that simple, powerful idea,
Yeah.
the actual tooling started its own long journey. Walk us through that first version. How did it tackle that initial copy-paste problem?
Right, so the very first iteration back in '96 was called Jamal. It stood for just another macro language. And it was written in, get this, about 300 lines of Perl. Its initial job was exactly what the developer needed. Include files, automatically update the documentation bits. Basically, you could point it at a code snippet and bam, it pulled that code right into your document.
300 lines of Perl. So like a very clever early include statement just for text files.
Mm-hmm.
Did it stay that simple or did it start, getting more features?
Oh, it definitely grew. Quite quickly, actually. It moved beyond just docs pretty fast.
Mm-hmm.
It was used to unify makefiles for script basic, across Linux and Windows.
Mm-hmm.
You'd have one makefile.jam that generated the platform-specific ones. It even got used for maintaining web pages. And over time, Jamal evolved into this really complex, powerful templating system. It got built-in macros, user-defined macros, conditionals, loops, the works. The last version of that Perl code was apparently from around 2010. Which, by then Perl was starting to feel a bit like a legacy language to some.
Fascinating. So the tool itself was growing alongside the developer's needs and the shifting tech landscape. But then as the developer took on a new challenge writing their first book, they hit a wall with Jamal. What was the issue and how did that lead to the Python version?
Exactly. Yeah, the book writing highlighted a limitation. With Jamal, when you were actually editing the source document, you only saw the references to the code snippets, like include code.base% or whatever. You didn't see the actual code itself unless you looked at the generated output. So you needed multiple windows open, constantly jumping back and forth. Not ideal for writing flowing text. So Piyama tried this fundamentally reverse approach. Instead of taking a source file and generating a new output file, Piyama acted more like an offline editor. It would process commands written directly into the document and update that document in place. It was a really subtle shift, but it kind of challenged the usual laws of physics for document generation back then.
Whoa, okay. That's a pretty radical concept for documentation tools. You're saying it modified the original file instead of making a new one. That sounds almost dangerous.
It was certainly ambitious. The goal was to give you that YLSI, what you see is what you get feel, while still having the automation underneath. But yeah, there's a telling anecdote here. The publisher for that first book absolutely insisted on Microsoft Word, which, of course, made PAMA completely unusable for that project. A classic real-world roadblock, right? But interestingly, for the second book, which used some online WYSIWG editor based on HTML, the developer actually used some custom scripts and Chrome debug tools to kind of hackishly apply PET principles anyway. Shows the dedication to the idea.
So already finding workarounds to keep the dream alive. Okay, so learning from Piyama and those other scripts, the project then embarked on its most ambitious phase yet. The Java version of Jamal. What did that bring?
Yeah, this was the big one. A complete overhaul, really. Much cleaner design, split into proper modules, and it ended up with over 200 macros. It was designed to be seriously robust, very versatile.
200 macros. Wow, that sounds incredibly comprehensive. What kind of things could it do?
Oh, pretty much anything you could think of for text generation. Basic stuff like if and for loops within your docs, but also pulling and formatting text from all sorts of places. JSON, XML, YAML files, even fetching data directly from SQL databases. And it was built to integrate really deeply into developer workflows. It had plugins or acted as a preprocessor for Maven, AssiDoc, JavaDoc. Even had some integration with Microsoft Word. Plus, it could include code snippets from Java, Groovy, JRuby, Python. And it even had its own little native basic interpreter built in.
Okay, that sounds genuinely like an enterprise-grade tool. Super powerful, super flexible. But I remember reading a warning from the developer in the source material about maybe not using Jamal for everything. What was that?
Yes, that's a very revealing point. The developer specifically cautioned, quote, "Do not use the macro extension and do not create your pom.xml files with the mall macros. It is not a good idea." They added, "I have learned over the years. These days, I try a different approach to avoid the XML configuration hell," which I think highlights a crucial lesson. Even with amazing tools, sometimes over-automation can create its own complexity nightmare. But despite that warning, this Java version was seriously sophisticated. It even had advanced debugging features like extensive XML trace output and a dedicated React.js debugger front end.
Right, so with all that power, 30 years of refinement, you'd really expect Jamal to be maybe not a household name, but definitely well-known in dev circles. But here's the paradox, the surprising bit. The Java version, despite everything, has only 63 GitHub stars. And the developer themselves says they're not aware of anyone using it. So what gives? Why did this apparently powerful solution to a real problem just fizzle out, seemingly, before the LLM era?
It's the crucial question, isn't it? Why didn't developers jump on this? The source material points to a few key reasons. First, just the sheer complexity and the learning curve. With over 200 macros, Jamal is described as too complex to start with. Just finding the macro you need is a significant effort, apparently even for the person who wrote them all.
Right. So feature-rich accidentally became feature overload, a barrier to entry.
Exactly. And second, and this is probably the big one, developer priorities. They just aren't aligned with documentation accuracy in the same way they are with code functionality. As the developer puts it pretty bluntly, a text document may be incorrect, outdated, even unreadable, but it never causes a build failure. Developers are measured by working code, test failures, production incidents, not usually by how perfect the docs are. And PIT, remember, could actually cause build failures if the source it linked to changed or broke, which is exactly what developers try to avoid.
Oof. Yeah, that's a really stark, pragmatic truth about software development. Doc errors are annoying, code errors are emergencies.
Precisely. And then there's the question of, well, who actually needs this?
Sure.
The developer observed, developers do not need program-enhanced text. Enterprises do, but enterprises do not select technology. Developers working for the enterprises do. Kind of catch-22. And finally, the elephant in the room, the thing that really seemed to doom Pete adoption back then, the developer's conclusion was simply, nobody reads the documentation.
Wow. Nobody reads the documentation. If that's true, why bother with all this complex automation, right?
All right.
But this is where the whole story takes a completely unexpected turn. Just when it seems like PD and automated docs are maybe a lost cause because, well, nobody reads them, suddenly, large language models arrive. How do LLMs completely flip this script?
It's a massive paradigm shift. It's really fascinating. The developer, who mentions having a soft spot for scripting languages and a long history going back to learning from the classic Dragon book on compilers in 1987, they started experimenting. They created a new language called Turicum. and tried feeding its user guide to LLMs. And here's the absolute kicker. It is no longer true that nobody reads the documentation. It is the LLM that reads the documentation, and the users can ask questions.
Wait, hold on. So the very reason it wasn't adopted, the idea that humans don't read docs, is now the reason it's suddenly super relevant. Because AIs do read them. That's incredible.
It's a wild twist, isn't it? So when they fed their Terracum documentation to ChatGPT, the factual text parts were handled well, but any code fragments were just hallucinated, made up, wrong. But what's truly amazing is what happened next. They asked ChatGPT how to improve the documentation to stop the hallucinations, and the LLM itself suggested adding a BNF, a Bacchus-Naur form, basically a formal, precise description of the language's syntax. And guess what? That advice actually worked. Adding the BNF not only stopped the hallucinations, but even helped ChatGPT solve the complex 8-queen problem using the Terracum language kernel.
Oh, the AI is literally telling us how to write better docs for the AI. That's a powerful feedback loop right there. So what does this mean for how we should actually write documentation now in this new world?
Well, it implies a really profound shift in focus. We probably need less of the explanatory and glue text, the narrative stuff. Instead, the focus needs to be on precise reference style description. Things like an eBNF that's extended Bacchus-Naur form, a more flexible version maybe with just some concise comments. And this kind of precise reference style text is the absolute sweet spot for Pete. Because there's less need for explanatory text and more need for reference text to be fed into the LLM, the value of those automatically generated, always correct fragments goes way up. These precise bits, like an eBNF for a command, can live right inside the source code comments and be automatically pulled out by a Pete tool, something the developer says they did many times, utilizing Jamal's snippet functionality.
Ah, okay. So Pete ensures that the crucial reference info the LLM needs is always perfectly aligned with the actual code because it's extracted directly from the code's vicinity.
Exactly. It keeps the documentation synchronized almost automatically because, let's face it, it is more likely to update the eBNF description of a command whenever the syntax changes during development if the eBNF is part of the source code. If that definition lives in a separate document somewhere else, it is easy to forget to update, out of sight, out of mind, which leads right back to inaccurate docs, which LLMs will then misuse.
Okay, this makes so much sense now. The LLM becomes the primary reader that benefits most from PT's core principle. So what does this mean for you listening right now? How can you start embracing these advantages, this new way of thinking about docs for LLMs, without necessarily picking up the heavy weapon, as the source calls it, of a giant 30-year-old tool like Jamal?
Right. The developer actually thought about that exact scenario. What if you couldn't use Jamal, but you still wanted just one specific PET feature? Let's say hierarchical numbering in Markdown. Their solution. Remarkably simple. A Python script, just about 100 lines long, apparently vibe-coded with Claude, which is a nice touch, and it's up on GitHub. This lighter approach basically mixes your text with Python code snippets using delimiters like bedinu or percent and percent, very similar things like JSP or ASP, if you remember those. It can load helper classes and functions from a special .pet directory so you can keep things organized.
100 lines of Python to solve a problem that, in a way, took 30 years to build a full tool for. That's quite something. Speaks volumes about Python, maybe, but also about maybe a more focused approach being enough now.
It really does. And that specific example, the hierarchical numbering, was implemented in just 80 lines within that framework. The core message here seems to be, you can probably script other specific PT-like features you need, maybe extracting code comments, including file snippets in just a few minutes or hours, tops. And all you really need is Python, which chances are you probably already have installed. Now, the developer isn't saying you must use this specific library instead of Jamal. They're pretty clear. Use Jamal if that fits you. Use this library, copying it, modifying it. Use something else utilizing Python, Groovy, Ruby, or Rust to your taste. What they are strongly advocating for, the key takeaway, is using program-enhanced text PT documentation for any technology. The principle matters more than the specific tool.
Okay, so we've really taken a deep dive here into this incredible 30-year saga of a document automation philosophy, PET. We saw it grow from this tiny Perl script addressing a simple need into this huge, complex Java tool. We understood why its very complexity, combined with, let's face it, traditional developer priorities and the belief that no one read the docs, kind of hindered its adoption for a long time. But then in this really amazing twist, the rise of LLMs has suddenly given PE this new, absolutely vital role. It transforms documentation from something maybe ignored by humans into critical, precise reference material eagerly consumed by AI, making that automation and maintenance more important than ever before.
Exactly. So It leaves us with a really provocative thought to consider. If LLMs are indeed becoming the new primary readers of our technical documentation, and we know they thrive on precise, automatically updated reference material, how does that fundamentally change the way you need to think about the purpose, the structure, even the value of the information you create and share? What pieces of information are you maybe duplicating right now across code comments, readms, wikis, user guides that could potentially be generated from a single source of truth, ensuring consistency not just for your human colleagues, but crucially for the AIs that are increasingly relying on it?